All right, today's the first of two videos on inverse functions. Inverse functions, what they are, what we're going to do with them, and everything to do with inverses. So here we go. An inverse relation. All you do for inverse relations is it says this: you interchange the first and second coordinates of each ordered pair in a relation that produces the inverse relation. So these two relations are inverses of each other. Remember, a relation is just a set of ordered pairs. So you take your x and y here, you switch them. Your x and y there, you switch them. Your x and y there, you interchange them. X and y there, you interchange them. That's what makes an inverse, is when the x's and y's are switched or interchanged. If a relation is defined by an equation, interchanging the variables produces an equation of the inverse relation. So this problem right here says find an equation for the inverse of this. All they're asking you to do here is interchange your variables. So x equals y squared minus 5y. And that would be your inverse relation when you interchange them. If you were to graph them, you would see something pretty interesting. Actually, I'm going to pause this a second, take a picture, and show what the graph of those two would look like. All right, the picture's down on the bottom, and it looks crazy. It comes like a heart, kind of diagonal when you look at it at first, but you really got to look at the picture and see what it's saying. This, the red graph is the graph of our inverse, what we found right here, the inverse relation. And because it's y squared instead of x squared, it's a sideways parabola, so it's a parabola going sideways. The blue one, the blue graph is our original graph. That's a x squared, so it's a parabola that opens upwards like that. And so if you look at the line going right through the middle, they drew this line right here that says y equals x, that broken line. Notice it splits them directly in half. The blue is reflected across that to the red. That's always true. Anytime you draw that line and you graph two inverses, that's how you can tell two functions are inverses of each other, is if they're reflections across that line. It's always y equals x. So you're going to see some graphs today and tomorrow, and that's always going to happen. Now, y equals x line is a big deal. All right. Here's more examples of inverses, or what's called one-to-one functions. These are called one-to-one. One of them is, and one isn't actually. This first one is not one-to-one. What happens here is this is the, you can tell what it says. It's a postage, first-class postage cost, but based on the years, obviously it's gone up. So, like, each year is going to one price. So what's happening there is that is a function, right? But if you turn it around this way, if you do the inverse, if you switch the x's and y's and make this go this way and go that direction, all of a sudden it's not a function anymore, because when these become your x's, they're going to two different y's. Now, if you look over here at the cube function, this is like 1 cubed, 2 cubed, 3 cubed, -1 cubed, 0 cubed, and this is what you get. Now, what happens is every number has exactly 1 cube. So that's a function because all the x's are going to 1y. And when you turn it around, look at this. When you turn it around to where your y's are now your x's and your x's are now your y's, it still just goes to each one, just goes to 1y. So this right here, these two on this side are called one-to-one functions, because every x has 1y and every y has 1x. Or if you do the inverse, it's still a function. And there's a couple of algebraic definitions here. Let's see if they make any sense. It says a function is one-to-one if different inputs have different outputs. So every x has 1y. If a does not equal b, then f of a does not equal f of b. Or a function is one-to-one if when the outputs are the same, the inputs are the same, which is what we just looked at. Right? If you switch them around, they're the same. Also, another little definition here for one-to-one functions and inverses. If a function is one-to-one, the inverse is a function. And this is a symbol for inverse, by the way, little f -1. Anytime you see a little -1 as an exponent, it's going to mean inverse. I should have talked about that already. The domain of a function, of a one-to-one function f, is the range of the inverse of f. If that's one-to-one, your domain and range just switch. Your x's become your y's become your x's, so your domain and range just switch. A function that's increasing over its entire domain or is decreasing over its entire domain is a one-to-one function, meaning if it's linear, or if it's cubic, something like that, if it's increasing or decreasing, there's no, how can I say this? No hills or valleys in it. It's always one-to-one. You can tell by looking at the graph. A little more informal definition that I found: one-to-one functions, every x corresponds to exactly one y, and every y corresponds to exactly one x. That's what makes it one-to-one. Also, you can tell it's 1-to-1 if it passes the horizontal line test. Meaning, if you look at these 4 pictures down here, there's a red horizontal line on this first picture right here. That's part A. The red horizontal line only crosses the graph one time. That's linear. It's decreasing the whole time. So that would be 1-to-1. The second one right here, the parabola, notice the red line crosses it twice. It crosses it at -2, 4, and +2, 4. And also, you could draw it up here, cross a couple more times. That would not be 1-to-1. It is a function because it passes the vertical line test. It is not 1-to-1 because it does not pass the horizontal line test. Part C down here, that one definitely is. If I draw a horizontal line through there, no matter where I draw it, I'm only going to hit it one time. So that is a function. It's a 1-to-1 function. Part D is a function because it passes the vertical line test. It is not 1-to-1 because you can see the red line, as I just drew it in blue, crosses it more than once. So that's the best way to tell if something's 1-to-1 is to punch it in your calculator, see if it passes the horizontal line test. All right, last thing today. Obtaining a formula for an inverse. They're going to give you an equation today and say find the inverse of that equation. Here's the steps we're going to do. The weird steps. We're going to replace the f of x with y, because that's what f of x really is. It's different notation for y. We're going to interchange the x's and the y's. We're going to solve for y, and then we're going to take the y back out and put the f -1 in its place. And I have an example down here. Just going to show you real quick. It's not hard at all. So here we go. First of all, replace f of x with the y. So I'm going to put a y here where the f of x was, equals 2x minus 3. Now it says interchange the x and the y. So I'm going to put the x where the y was, the y where the x was. That's step 2. Step 3 says solve for y. So I'm going to get the y by itself. So I'm going to take 3 to the other side first. Make it x plus 3. Divide by the 2. So I get x plus 3 over 2. Now that's step 3, solve for y. And the last step, it says replace your y with, what's going on here? Replace the y with f of x. So my last step, I'm going to put f -1 of x, which means the inverse of f. The inverse of what we started with is x plus 3 over 2. I'm going to show you 2 really neat things right here before I close this video out. I hope you think it's neat. I think it is. Okay, when you started up here, if you look at the x, they subtracted 3 multiplied by 2. Subtracted 3 multiplied by 2. Look at the answer. Added 3 divided by 2. Inverse means opposite. The opposite stuff happens. Let me show you one more thing. Now I'll close it out, I promise. What if I plug in 1 in my original thing right here? If I plug in 1 right there, 2 times 1 is 2, minus 3 is -1. I'll get 1 -1. Now, let's reverse it down here. What if I plug in -1 in here in my inverse? If I do, on the top I get -1 plus 3, which is 2. 2 over 2 is 1. Look what happened. Are you kidding me? The x and y's switched. Who would have thought? Well, I would have. Hopefully you would have too. Okay, this is part 1 of this lesson. Hopefully it wasn't too bad. We'll work on it tomorrow. See you then.